So unit number 7, in unit number 7, we're going to be talking about writing reports with statistics. This unit is very critical. Why? Because in your final assignment, you will be doing the combination of what you did in the previous unit, which is the pivot tables, and then you're going to write conclusions about them, and you're going to do a whole report about it. And this is where this unit is going to become very critical, because you must know how to write professionally. You cannot just say, this one is bigger because I think probably this happened. No, you have to demonstrate it with numbers. You have to use the accurate language, and then you have to present it in a clear and concise way. So let's go to that. Okay, let's go to, first of all, let's look about writing statistics reports, some guidelines that you need to follow throughout your whole career. This is not just about your report. So first of all, never calculate or statistical procedures you don't understand. I'm going to use the standard deviation, but I don't even know. But sounds good and it must be there, but I don't understand the standard deviation. I don't understand a correlation. I don't understand a coefficient of variation. Don't use them. If you don't understand them, don't use them. Use those that you understand. And the same thing, don't interpret the results of things you don't get. If you don't understand it, don't try it. Consider your audience, who you're talking to. If you're talking to your bosses, if you're talking to who you're talking to. For example, when you're doing this report, you're talking to me. I know more than you, so you have to address it in a more professional way. But what happens if you're addressing a population that hardly knows how to read? So perhaps using graphs, it will be much better. Think of this, for example, you work in a construction and you need to tell your employees that they need to wear the safety devices, and they have no education. So you have to do it with graphs like, look, this is the number of accidents, and then you show a graph that is much bigger than the other one. Visually, they will understand that much better, right? Present as much information as you need so the reader can interpret the data by himself. So if you tell me this number is larger than the other and as comparison to the remaining of the numbers, that sounds fantastic, but why don't you put a table? Then on the table I can look for it, I can assess it by myself, and then of course that's gonna sound much better. Now use graphs and tables. You have to graphically show what you're saying if it's possible. That helps all the time because you can see quickly, in a nutshell, at a glance you can see it, right? After that, you have to think whether you have to apply variability to it. If there's a standard deviation and how it behaves, is it useful because it's normally distributed or not? Be careful using statistics that are from other places. You try to link them, but they don't link at all. And the same thing, you have to provide information to your audience where you acquire this information, where this data set came from. If you don't have it, then you have to state it as well. If you calculate the statistics, how you reached it, why you use an average, why you use a standard deviation, what is the purpose of that, what you were trying to achieve out of that, and what you can show out of it, right? Again, choosing the model. You have to explain why you choose that model. The same thing, you have to be clear on what population you mean. Is it a sample or is the whole population? You have to understand that. And the same thing in inferential statistics. We'll talk about inferential statistics, but mostly it's trying to talk as plainly as possible. Well, actually, in general, you have to do that. So descriptive statistics, in descriptive statistics is very simple. What we see is what we address, right? If we see larger, smaller than that, we don't have the difference as, for example, when we have inferential statistics. In inferential statistics is different because I have to make assumptions out of a population. Say, for example, I have only 10 observations out of 100 people. I have to be very careful of how I'm going to write it because I cannot assume that 10 is really the reflection of 100 people. So we cannot generalize of the larger group. And also we have to think of, for example, in inferential statistics, like correlations or connections of the data. So that is very, very tricky because in correlation doesn't mean causation. Not because something is connected, that means that that is true. That is the case. For example, there was a very useful graph, and I think I showed it before. That there was the more the lemons were imported into the U.S., the less car accidents they were. So they are perfectly correlated, but that doesn't mean they are connected at all. So in this case, correlation doesn't mean causation. So we have to get that very clear in inferential statistics. Okay. So when we write in the descriptive statistics, we have to be direct. That's it. Present visual ways, our graphs, our tables, and we should use very simple things like the mean and the standard deviation, where everything is centrally located, and after that also how much variance is within this data set. I had to turn on the light because you cannot see me. Okay, so anyways, so in this case, like I said, inferential statistics are slightly different than descriptive statistics because we try to guess more. And in those statements, we have to be a bit, although we have to be clear, we cannot assume that everything happens all the time. Okay, so we have presenting the data graphically. We have a couple of examples. We have dot plots to see we have to see a scale, and then we have to mark an axis and then plot each data value based on that scale. So actually pretty much this is a dot plot is very similar to what we do in a histogram. It's just that we do it with dots rather than with bars, right? So in this case we also measure the frequency. Histograms, you know them very well. I'm not gonna go through that anymore. Line charts, the same thing. Line chart, usually we see it for time. Whenever we want to see the exponential growth or something over a certain period of time, line charts work very well. Column and bar charts, the same thing. When we want to look at the individuals, we use the bar charts. Remember not to confuse them with histograms. Now here, parenthesis, we can do on pivot tables, we can do histograms. We cannot do them, so we have to export the data, put it in another sheet, and then calculate it. Pie charts, in this case, we want to see what's the majority. We can see it very quickly. In case we want to see the max and the min, that works very, very, very well, right? And then we have scatter plots. The scatter plots are going to be useful to represent the correlation between two points, two things, right? So in this case, we can see how they connect. If we can see a perfect line together with all the dots, that means they are highly connected. We investigate relationships with that. So now we do tables, and the tables, well, pretty much is when we have very large sets of data, we try to summarize them in a table, and that we present it to the viewer, and somehow they can assess also very quickly what's going on in there. Okay, very good. So structure of statistics report. So first of all, this is a very general one. Of course, every report varies, but in general, we have the executive summary, which is in a very brief way. We explain what is going to happen throughout this analysis, why we decided to collect this data, and what we achieved. So in a nutshell, it's like for your boss, he reads executive summary, and with that one, he doesn't need to even read the whole report, right? So if you can summarize it very quickly, he's interested or not. Hypothesis. In this hypothesis is your first ideas. So in this case, it's like, I believe that by measuring this and that, or I initially started believing this and that, and then finally I will try to prove it by using this method. So in this case, you're gonna try to say, I will collect the data in this way, I will try to prove this, and I will use the following methods. And that goes together with the next section, which is the methodology. What models am I gonna use to prove or disprove these ideas that I initially have? Then we have the most important part, which is the data presentation and discussion, where you really just go and address every single point that you wanted to discuss in their hypothesis. You address, you discuss it, you look at the positives, the negatives, what you probably missed, what's accurate and what's not. Then we have the conclusions, which is you make a whole summary of the whole thing. right? We analyze the growth, we analyze the profit, we analyze the revenue. Together we can assume that the company is very profitable. Yes, it has some shortages in some certain areas, so we need to address that. So it's a conclusion. Then we have the limitations. Limitations, you write them when you are missing data or when you're not very clear and you say, well, I address this problem in this way. However, I'm missing some information. So if I were to have that information, probably my level of confidence will be much higher. Then we have recommendations in the future. I think if we analyze a larger sample, that could be better. If we were to collect the data on times that are more accurate, if we had more funding. So things that you recommend for the next time that someone tries to address a similar study. And then appendices and tables. When you have to take care of the flow of the report. And if the flow of that report breaks because you need to put very large graphs, you can just send them to the appendix. So the last part, and you can see section number 1. In this section, there's this large table. You can refer to appendix 1. So the reader is going to jump to the section 1 of the appendix and check that graph by himself because it's too large to be in the report. It breaks the whole flow of everything. Now, so why do we do statistics in business? I think this one you already get it, but in general, we use statistics to understand what we have done, where we are, and predict what could possibly happen, right? So in this case, we can take better managerial decisions. We use all that information for knowledge, and then, yeah, probably we can take much better decisions rather than just guessing what could possibly happen. So now we have, this is, I think, one of the most critical areas, which is holding ethical standards in statistics, which is we cannot create our own procedures. We have to use those established already by statistically already established. Data integrity, we don't what happens if your boss says, the sales of this month are not very good, so why don't you just fix a bit the numbers on the spreadsheet and we won't get scolded. Probably next month we will do better, so let's try to change it. Then you go ahead because he's your boss, so that doesn't work. That you should never do it. The same thing, carry out accurate calculations. You make sure you double check that. Not because it's Excel that means it's accurate. Sometimes Excel also makes mistakes due to the programming, so you have to check that. You have to report the procedures faithfully, meaning in good order, and that you carried them out with due diligence. You have to protect confidential information. This is ethical. Sometimes you collect some data and you're not going to share it with anyone that is not related to the study. Okay. You have to cite sources in case it's necessary, and then acknowledge sources of financial support in case you had them. This goes more for professional life. All of them are more for professional life. Now let's look at some common mistakes that you do when you write about statistics. So first of all, you take conclusions from small samples. So in this case, I examine only 2 people of a class and I can assume that 60 people will behave the same. Nope. Then I need at least 30, 40 in order for me to really say that that sample is valid, right? Conclusions from non-random examples. Say, for example, rock stars die young. So Buddy Holly, Jimi Hendrix, Janis Joplin, Jim Morrison, John Lennon, and Kurt Cobain. So that is not the rule. I'm just randomly choosing rock stars. If I were to look at all the rock stars in all history, perhaps the history will be much different. So you have to be careful with that. Conclusions from rare events, and that is also very similar to the previous one. You need to have enoughly large sample. We say in statistics, we have the law of the large numbers. The more you repeat it, the more accurate it's gonna be. So we say in statistics, the minimum for us to consider something valid is 100 observations. The minimum. Of course, sometimes the population is small, it's 20. You observe the 20 and that's it, if you have that ability. Okay. Then we have the per sorby methods. You are biased with your questions. Do you prefer rock and roll or rap? I don't like either, but I have to choose one. And then you're gonna say, "Ma, most of the people like rock and roll." But no, I mean, within those people, you give them only those two options. And then assuming a causal link, like I said, I have already explained how correlation doesn't mean causation. Not because two things are connected, that means one caused the other. Okay? Not because very simple thing. Not because it's winter, that means some couples break up. That is it's because of the bad weather they break up. No, there's no connection in that, right? So we have generalization to individuals. Men are taller than women. Yeah, you can see sometimes this case happens, but maybe not in every society, so you have to be very careful with that. Then we have to talk about unconscious bias. You have bias within your brain, whether you know it or not. Okay, it may happen that, for example, you have the statistics of all the employees of the company, but one of the employees is your friend, and so you start to think that his performance is not that bad, but you're already creating that bias. So it's an unconscious because he's your friend. So you have to be very careful with this unconscious bias. And then finally, significance versus importance. Sometimes there's connections between the data, but that doesn't mean that that connection is relevant or important, right? I think I explained in the lesson itself that and you can check that out. But it's the same thing with correlation and causation. There's correlations that are very strong. That doesn't mean that they are important. Okay, so we need to look at their significance. Very good. So now your assignment for this week, you're gonna be looking at unit number 6. You were writing conclusions about your pivot tables. So you're gonna look at them back again, and then what you're gonna do, and give me a second, and then what you're gonna do with those 3 conclusions you wrote for your 3 pivot tables, you're gonna rephrase them based on what we saw on this unit. Okay, so the first thing, when you're writing statistics reports, you cannot put I believe, I think, this graph shows, the data shows, not I found, it can be seen. Always third person. So this graph shows, not on this graph I put X is bigger than that. Then you will write first what kind of data you're dealing with. So you, as an introduction, you're gonna write, okay, this data set is about a company that sells for example, cars, and we have 15 variables, we have 3 elementary units, and with that we're trying to find out what are the average sales per car, for example, right? This one was a supermarket, so you already know more or less what you're going to write about. Methods that you used and why you choose those methods. So for example, when you're writing, I mean, this goes to each specific pivot table. So pivot table 1, in this pivot table 1, I use summary. I use average summary. So in this case, this was necessary because I want to look where mostly the data is concentrated. Okay, so you use that method, and then you're going to explain it in there. You must mention basic summaries for every single pivot table. What was the lowest? What was the highest? What is the average? And how the data is distributed. Is it skewed data, or is it normally distributed? Okay, then on the next one, the next thing, you are gonna add also measures of variability, specifically standard deviation, and you're gonna write an analysis of it. I see that in this data, the data is very linked in the middle, or somehow is sparse because it goes to the sides. You're gonna add a graph for each pivot table. Which one depends on the situation. It can be a pie chart, a bar chart, a map, etc., etc. And then you're going to write limitations of this graph. So in this data set, or in this pivot table, I cannot do this because I don't have this information. I don't know whether Nancy Freehaffer has this information or not. So you're going to write all the limitations as I explained in the unit. And then you're going to do a conclusions of compile of the 3 observations in one single paragraph. So in this case, we're going to see, okay, so this graph, with these 3 pivot tables, we were able to understand the performance in terms of the sales, in terms of the revenue, in terms of something else. We put them together, we realize that the company is performing very well, but we need to address some of the issue of the locations, etc., etc. Okay, so if you have any questions, do let me know, but again, this is mostly what you need to follow. So thank you so much. If you have any questions, please ask me anytime. Thank you so much, and I'll see you soon.